everybody. I'm Jess from Think and Act Differently, powered by BHP. It's wonderful to see so many familiar faces and some new faces on the call today. As always, it's important that we start today by acknowledging and paying respect to the traditional custodians of the land and the waterways on which we work from today. We pay respects to the elders past and present, and we extend that respect as well to Aboriginal, Torres Strait Islanders, or any other Indigenous people who join us around the world today. So thank you for being here. And thank you to the fabulous team who joins me. You'll get to hear from a few new people today. We have Claudia Hernandez, who's on the line, joining us all the way from South America. We also have Chris Elkins, and you've met Holly already. So just quickly, we've done the welcome and introductions. We'll talk a little bit about the opportunity streams that we're most interested in today. We'll specifically dig into the nitrous oxide challenge that we've launched very recently. We'll talk about our focus in copper, and then we'll make sure we have a lot of time to answer your questions and have an open conversation at the end. Also, as Holly mentioned, you can throw your questions in the chat, and we'll try to answer those as we go if it makes sense too. So whether you've met us or not before or not, thank you for joining. TAD is all about connecting the opportunities of BHP and of our partners to all of you. And we do that in a way that we hope to create a fun space where you can do the very best work of your life. We try to provide the variety of resources that you need to accelerate your ideas. And we really like to make sure that you know we're not a one-size-fits-all kind of shop. We want to get to know you and your idea, and we want to find a way to de-risk your riskiest hypothesis and get it on the shelf faster to create change. I have to do some muting magic, Miss Holly. So if you joined our last webinar, you probably saw these for the first time. We did figure it was worth just mentioning them again. So when we formed our United TAD powered by BHP in September, we really started thinking about where we need to focus our efforts. And while the open house provides a really unconstrained space for you to give us any idea you think you can help, it's also a two-way conversation. And so it's important for us to make sure you know what we're thinking about as well. So we've been refining our work plans around the opportunities that we see having the biggest impacts. And we're in the middle of assessing all the capabilities and technologies that we know about across this amazing ecosystem so that we can continue the conversation about where the work might be to fill the gaps. So we've structured our technical focus around the 5 areas that are on your screen right now. And the goal here is to connect the external disruptive trends with the internal BHP opportunities and those of our joint venture partners as well. So they anchor the forward-looking technology areas into the product roadmaps that we develop and deploy solutions for value today and value tomorrow. So let's skate on. Thank you. It's a funnel. We have a structured process. We get a lot of questions about this, which is why we put it up, even just to get a bit of transparency for what that innovator journey looks like. And to be honest, we're doing a lot of work in this space, so I hope to have some new things to share soon. But we do have a structured process to experiment, test, de-risk, and deploy technology as it scales across that funnel. And we're working to refine all of our processes to support innovators of any size at any stage of technological and commercial readiness. So that they can succeed the whole way across that pipeline. So we look at technology in systems aligned to concepts of operations. And rather than using a discrete solution, we hope to create a sort of more systemic, valuable, and sustainable change model, which is what we're all here to do. So I'm going to hand to Holly, and she is going to talk more specifically about the opportunities that we're the most interested in right now. And I'll hang around to answer.
Think and act differently करके कुछ group है.
Okay, back on my meeting. Thanks, Jess. Amazing. So yeah, thanks for running through that process, Jess. And to add to that, I think we do get a lot of questions about that funnel process. And in the next webinar, we'll probably be able to share a little bit more details on how we kind of go through some of those stage gates and those stages in a little bit more detail with some more of the TAD team. But keen to share to you a little bit about the open house. So as Jess mentioned, TAD runs the open house, which is our front door of innovation. And really the idea being here is for people to be able to submit any idea at any time that you think is something that you'd like to work on with BHP on, that you can deliver value to you and also deliver value back to BHP. So the open house is always open, and we do have kind of a structured review process. So we have dedicated, the open house is always on, but each quarter we have a dedicated month at the end of each quarter where we review the submissions that have come in over that quarter. So we're currently in the latest review phase now, which I know some of you on the call are part of. So we'll be getting back to you soon for those of you that submitted in the last quarter. So in the open house, we do have lots of different themes that we're focused on as well. So you'll see these come through. We've had, I guess, a flurry of activity over the last few months. And so I'm not going to mention everything today. There's a few things that are going on in the background that are not on this slide. For example, we recently closed out the Potash Challenge, which was run with the team, the Janssen team in Canada. They're currently reviewing those submissions and we'll be moving forward with some of those soon. So thank you to everyone that was involved in that. We have recently started off our essential minerals cohort with 10 innovators. I do want to have a shout out. She's not on the call, but Harshita has, from the TAD team, has been working very closely with the innovators to go through all of the procurement processes, which has been no small effort to get everyone onboarded for that. And that's like one of the key areas we're looking at improving for the innovator experience as well. Biometals and comminution, we were overwhelmed with a lot of submissions for there, and we know this has taken us a little bit longer to review than we originally planned because just of the sheer volume of activity, and we wanted to make sure we had all the right people in the room to review that. So if you have, many of you who were involved in that will have heard back from us, but if you haven't, you'll hear back from us very soon. We also recently launched the Creative Copper Recovery Challenge, which for those of you that were on last month's webinar, you would have had an amazing insight into all the background in heap leaching for copper. Please go back and watch that webinar. It's on the YouTube channel. If you're interested in that challenge, there is a really big unlock there. And today we're going to hear more about our newly launched open call, which I'll get to in a minute. And then, as Jess mentioned, we'll hand over to Chris to talk more about what we're looking at in general to innovating in the copper space. So the Nitrous Oxide Challenge. So this is a really, really interesting challenge. I'm not going to say much about it because I'm going to hand over to Claudia to give you way more details. But I will say that we've just launched this. It was open on the 19th of March, open until the 7th of May. This really focuses on helping to bring forward innovative solutions that can effectively recycle and repurpose gases. So this is a really interesting opportunity. So I will hand over to Claudia now to give you way more details on this challenge. Over to you, Claudia.
Thank you, Holly. Can you hear me well?
Yes, I can hear you perfectly.
Excellent. So for those who are not very familiar with a leaching copper extraction process, I can explain a little bit around the process. So in the left hand, you will see a picture of a typical heap leaching process. This is only as an example. This picture comes from Escondida mine in 2004. I don't know the specific size of this heap leach, but just for the picture, I can tell that it's around 100 meters by 200 meters. Current operations that we are looking for the future could be easily 3, 4, 5 times this size. So today, BHP is working to develop a new proprietary process for leaching that has shown to produce nitrous oxide or NOx gases. So we need to manage these gases, ideally to reconvert them and put them again in the heap leach in the form of nitric or nitrous acid. Okay, so typically to handle gases at this size, we will capture them, make them through a scrubbing system and monitoring gases, fugitives, and so on. But as you can see the dimension of the heap leach, this could be very complicated to do in this scale, right? So this is why we need to find new solutions to manage these gases. And if you move on, Holly, to the next slide, please. So there are still a lot of unknowns and no unknowns. That is, we know for the chemical process within the heap leach that how much gas will be generated inside the heap leach, but we don't know how much of these gases will be released from the heap leach. because as I mentioned, this is a new process. It's still a lot of work to understand everything, what is going on with it. But we do know a lot of things. For the chemistry, we will know how much gas will be created. We will know the mineralogy of the copper grade sulfide oxide mixes, what we decide to put in the heap leach, the particle size distribution that we will have, the heap dimensions that we're planning to have, and the chemistry of solution and oxidizing agents added to the process. As I mentioned, there is still a lot to learn yet, and we have some testing facilities that we are using to learn more about this challenge, that hopefully you can help us to find new solutions to manage these gases.
Well, yeah, I didn't put this on the slides, but obviously with this being like a future or something that is in development, in terms of trialing solutions that can help mitigate the gas, could you just maybe talk a little bit about what the setup would look like for demonstrating any potential solutions?
Yes, in regards timelines, we have, as I mentioned, some testing facilities in a small scale that we can use right now to test new solutions. And we're planning to have a demo heap leach very soon in operation. That is a bigger facility to test the process recovery itself, the new leaching process recovery. So eventually that can become also a testing facilities for whatever new solution we can find. So.
Okay, so Claudia, first one for you from Amado. What is the reagent that is promoting formation of NOx? I'm not sure if you can answer that.
It's a combination of them. So at this stage, I cannot share the details of the reagents involved in the process, but it's a combination of them. It's a chemical reaction that happens within the heap leach in combination of the mineral and the reagents that we put in there.
And so James has asked, and I think this is a good one to just clarify that this is not a current process. So James did ask, the gas generated in the heap currently escapes to the atmosphere.
No, no, it's not. We don't have an operation ongoing yet with this process. It's a lab scale testing yet, and a bigger lab scale that is very controlled. And the demo heap leach that we are planning to use the traditional methods to manage gases, that is putting a big cover on top of the heap leach and captures all the gases and make them through a scrubbing system. So this is why we foresee this will be complicated in a bigger scale, but we don't have an operation yet working with this new process. And this is the new solutions also to make it sustainable for the future.
Amazing. And I think this is a really important challenge, because it shows that, you know, a lot of these disruptive innovations, they're systems level changes. So we might innovate in one area, but then we need to innovate in other areas as well, so that we can actually enable these technologies to come to bear. So I love the fact that this challenge is challenging us to think at the systems level and look at the different areas that we need to solve for. So Ray has asked, is the NOx from the urea brackets jetty or an oxidizing agent? I feel like we're going to have a few of these we can't answer, but go for it. Can you read that one, Claudia?
Yes, I can read, but I don't know how to reply into this. No, it's not coming from Yeti. I'm familiar with that, and no, it's different one.
Cool. Dave, I'll come back to your question. I'll just go through more of these NOx ones first. And then Warren has asked, landfill gas collection systems recover methane. Could this translate to the NOx issue?
Sorry, Holly, you're going fast. Landfill gas collection system, that one?
Yes.
Yes, could be. Yes, we are open to look at different solutions. Yes, we can explore that.
Yeah, I definitely think this challenge, we really want to look broadly. There's so many industries looking at capturing gas for a range of different reasons. We know there's lots of people doing kind of methane capturing in the coal industry as well. And oil and gas. We're looking across agriculture and waste. So there's we're really, really keen to hear from people working in other industries from this challenge as to how this can apply. So we would love to see those submissions coming through.
The challenge is to capture the gas, right? So eventually, if we can avoid it, we will open to receive that kind of solutions also proposed here. But yes, if we can capture the gas, we can recycle, yes.
Another question from Amado. What is the amount of gas you expect per ton of ore?
Unknown yet, to be released, right? But in the chemistry, I don't have the precise number to share with you. We have it, but per ton, after that, we have a real scale heap leach is unknown yet.
And follow-up question from Timothy, how much leeway is there for reconfiguring the heap dimensions to make it easier to capture the gas?
Not that much, I guess. We work with high volumes and will depend on each ore body, how we can think about each leaching operation for different minerals, but I would say not that much.
Fair enough. And Ian has asked, is it better to reduce the NOx to N2 plus O2 and replace the current dose with more environmentally and higher performing lixiviants to enhance recovery?
Yes, we can assess that, but I couldn't for certain provide an answer.
Yeah, sounds like that would be a good.
We can break it down, yes, but we need to do a complete assessment and model the process to understand if it's convenient or not. Yeah.
So would that be something, Claudia, that you would be interested if someone submitted that as a desktop study to do through the challenge?
Yes.
And Andrew has asked, beyond the capture of gases, what have you looked at so far? Have you looked at bubbling towers?
We have looked at different kind of solution, different approaches, but bubbling towers, I'm not familiar with that one.
So it sounds like that would be a good thing to put in. Andrew, if you think that could be a solution. And Henry has asked, did you consider replacing heap leaching with different extraction technologies, ion exchange? For example, it will be completely different operational environment with multiple options for byproducts.
We're open to new processes all the time. Every ore body needs an assessment in regards which process we are going to use. So yes, if something comes up in regards a new extracting process, we can give it a look too. Yes, will be interesting to try. Yeah.
And Claudia, I don't know how much you can share, but is it worth sharing a little bit about Escondida as an ore body and why heap leaching is the primary method you would use?
It's because in Escondida case, we have a concentrator process and also a leaching process. And what we do is to send everything we can to the concentrator process, and then we will have some ores to be treated in the facilities that we have for leaching. So yes, we assess, it will depend on the grade and the kind of ore that we have, but we have different process running in parallel. And leaching is more environmentally friendly than a concentrator process. This is well known in the industry. So, but the difference is that the recoveries are higher in the concentrator process than in leaching process. So this is why normally the primary process for copper extraction is concentration.
Amazing. But keep the questions coming in. We have Ian has just mentioned that you've already successfully done trials on removing nitrates. So it sounds like that could be something of interest to see coming through the challenge.
Yes, I agree.
So Dave, and everyone keep the questions coming through for Claudia and any for Chris as well. Dave, you've mentioned that you need to talk about ways to maximize, that you don't need to maximize grade at the mill by using advanced leaching of low grade concentrate. I imagine, Chris, that's something you guys are looking into, but is there anything you want to talk to on Dave's comment there?
I would only add to Chris, I don't know if you've seen it or not, but I've already submitted proposals to BHP with respect to Olympic Dam, West Musgrave, Carrapateena, and a couple of other sites that for low-grade polymetallic and arsenic contaminated leaching, with also the possibility of byproduct recoveries, including possibly uranium and thorium. So I'd love to have a good chat with you about those proposals.
Yeah, and that will be super interesting. So, I mean, we've kind of highlighted two areas and just my initial views on why they're important. An additional point around sorting underground is that you're moving less waste above ground, so you're getting that decarbonisation impact as well. But in terms of how we're approaching it, it is a clean sheet concept of operations, clean sheet flow sheets, and we certainly have included concentrate leach in there as a module within those flow sheets. So there's definitely space to play with that. So yeah, it'd be great to talk about it.
And Chris, I know we'll probably go into this in a lot more detail in the April webinar, but is there anything you think it's worth sharing about the design philosophies that the team is thinking about to help people think about the kind of innovations you're looking for as well?
Yes, can I get back to you in a moment? Let me just bring them back up again.
Sure. In the meantime, a question from Debbie for you, Claudia. Are there other gases formed or only the NOx gas?
No, just NOx gases.
Thank you. Yeah, and keep the questions coming. We still have plenty of time for questions. And Claudia, I know we kind of mentioned this before. Timeline-wise, do you have any specific timelines that you would like for people on the call just to think about when you would like to start any trials? Is that next financial year? Have you got any dates in mind for when you need to be doing that work?
We could start this financial year as soon as we are prepared to do it so, and we have all the agreements and collaboration aspects and administration aspects on place. We can start tomorrow.
Okay, well, that's good to know.
Yeah, it's a good timing. So for us, this technology development, like the whole process is as soon as the better. So this managing gases will be the same, right?
And Ray's asked, do heaps need airflow for bacteria? So you have to manage that as well.
Yes. Yes. Today, the process considers bacteria. There are some, yes, it's a big scope process. Some cases we use and some cases we don't.
And Amado has asked if you've considered any other solutions already to capture the gas aside from covering the HEPA. Is there anything else that you've looked at?
We have another approach with some testing ongoing that I'm not sure if I can mention this online, but we are currently progressing on one alternative solutions to the coverings in the HEPA. So yes.
Chris, sorry for putting you on the spot, but did you want to jump back on?
Yes, can do. Thanks for that. So we're calling them design philosophies. They're not necessarily constraints, but if we think about what does mining or resource extraction look like in the future, please keep this in mind. So we want to move away from having people in the production areas, so people out of the pit and people from underground. So things like automation, sensors, robotics, etc., are definitely going to be a theme that you see in some of our work in the future. That also includes, well, how do you operate that? We still want people involved in the decision making. So remote operations is clearly also one of our philosophies. We want to be able to modularize this work. So if we were to put we may standardize around 5 million tonne per annum concentrators and build those up. It depends on what's going to be efficient and economical in the future. But we need the ability to be able to rapidly expand production as required. We want to move away from producing a concentrate. So, Dave, building on your comments, concentrate leach or straight leach to a metal product is the ideal outcome. As much as possible, tailings and waste rock should be repurposed, whether that be as backfill or as other products, is definitely of interest. We don't want to consume water. We want to decarbonize at the same time. So our base case won't be diesel trucks in our concept of operations. Obviously, grinding is a huge energy requirement, so we want to minimize that as much as possible. And our mining method that we end up choosing, we want to minimize the impact to above ground from community, cultural heritage, just a general environment perspective. So I don't think there's any surprises in there, but that's definitely the philosophies that we're taking forward as we go through this process.
Awesome, thanks, Chris. And another hard question for you, or maybe it's not a hard question, from Paolo. How would you prove the whole concept of operation? Mentioning, IAS simulator has been used by TAD and before, but have you any thoughts on how you're going to prove those concepts?
So several ways. So one is dynamic simulation and modeling of this work. So we will start with static modeling to kind of find where those areas of value or areas of opportunity are. That'll derive, well, what are the systems that we need to create? So as an example, underground fragmentation that could impact downstream processing, downstream grinding. What we require upstream is better ore body knowledge and sensing. So there's a fragmentation system that we're looking to develop as an example. We can simulate all those parts in pretty good detail in terms of understanding the impact of changing technologies. But also, what was shown before around the TAD process, you've got discovery, develop, demonstrate kind of process areas or technology development areas where that's where we will be doing small scale pilots and large scale pilots into the future. So the idea is to take these different ideas, understand each of the technologies better, and then eventually build those systems that can be implemented within the BHP ecosystem.
And Amato's asked a question around, and I guess I have a few people can answer this, but is in situ leaching an option for Copper South Australia?
Yes.
Yes.
But we kind of see that in that 10 to 15 year horizon. Yes.
I do think it's worth noting that the TAD team in general do focus on different time horizons. So we are really interested in disruptive technology, and there is a live cohort that is being supported by TAD and the joint venture partners in the ISR in situ recovery space. So it's a very interesting area for TAD and BHP. So whilst that is an active cohort, we are still looking for any new ideas in that space as well. So definitely of interest.
So Paulo, you also mentioned the IES simulator. So yes, absolutely. I mean, so we worked with Orica in the past. Really good at processing technologies, kind of good at leaching. What we want to do is also get those upstream processes and kind of integrate that, so you can see across the whole value chain.
And Claudia, back to you with a question from Pim. Have you considered microbial NOx production for reuse of nitric acid? You probably wouldn't get around a cover of some sort.
Conceptually, yes, we have thought about it, and we have no work done around it yet, as the process itself considers is a bioleaching process. Could be some way to collaborate. Yes, it could be. So far, we have not activated any collaboration around that.
And Claudia, I wonder, I don't know if there's, again, an easy way to share this, but is there anything you can share in terms of the things that you have looked at and why in general they worked, or what kind of things, what kind of reasons there have been for the things you've looked at not necessarily being suitable?
So we are trying to find someone to collaborate around in situ chemical oxidation, for example, approaches, geological also, geological approaches too. This is what I can remember right now, and I can share. Yeah.
Awesome. Okay, great. Okay, I'll keep the questions coming through. Otherwise, we can wrap up a little bit early. But I appreciate all the amazing questions that are coming through and helping everyone understand these challenges a little bit more. Chris, Jess, Claudia, anything else you wanted to share while we've still got a bit of time left?
I'm just excited by all the innovator engagement and all the really great questions. So I'm grateful for people leaning in and talking about it with us.
Yeah, absolutely. Anyone on the call want to come off mute and share a little bit about what they might be thinking on any of these challenges?
I'm loving the metaphor in the chat about a cake.
Good morning, everyone. Just have a quick question in regards of our previous discussion we had a month ago. It's about copper leaching in South Australia. According to BHP website and the Bureau of Veritas website, it was a heap leaching trial for 7 years. And it was declared successful, but no more information can be found about the results. In terms of this challenge which coming for BHP leaching, which was discussed last time, can we have access to this result, at least for somebody who will be qualified as a contender to this challenge? Because it'll be very interesting to have a look what's the chemistry and what approaches already was used for 7 years. So it will be much easier to start not from the zero, but from some sort of previous, significant attempt to solve it. Any ideas about this information? Can we have a look on this, please? Thank you.
Thanks, Henry. I will definitely follow up and see what we can share in that space. I think obviously that there's only so much we could say and on this in the public space, but I think looking at the key areas of that challenge will give you indications of what potentially that trial wasn't able to solve. So I think with the current focus areas of the challenge being specifically around multiple extraction of multiple metals, particularly so looking at the multiple metals that were specifically within Olympic Dam, and kind of trying to speed up the cycle time as well. So I suppose I can't specifically say, but if you look at the areas of focus that have called out for that challenge, kind of I think should highlight where previous trials weren't able to deliver those elements. But I will follow up and see if we can share more direct information of that with the team, technical team internally, and get back to you.
Excellent. Thank you, Holly.
No problem. Yes, and I said Ian did mention that there is a press release, but I think that's what Henry's referring to. There is a press release, but obviously it doesn't contain the level of information that would be helpful. And so, yes, of course, absolutely, there's internal BHP reports, but we have to make sure that if that's something that we're able to share externally, and at what stage. So Claudia, another question for you on NOx. Is it being formed in the context of a bio leaching or chemical leaching?
Both. For the new process, I can say both, yes. Let's say it's more than one process and has some variations, right? Different ways to be used. So yes, both. We eventually will have bacteria present, and sometimes today, yes, we do need to force aeration, yes.
Now, Luke Berry, you keep coming off mute. Did you want to jump on the call? I keep muting you again because of background noise, but I just wanted to check. No. Awesome. Well, look, I'll give everyone a few more minutes to pop any more questions in that you do have. I wanted to echo Jess's sentiments that these webinars are awesome, and we really appreciate the deep engagement that people come through and it's one of my favorite ways to start the day, talking about all the exciting things that are going on. So appreciate everyone leaning in. Ray's just shared a little bit more on the chat, Henry, that might be helpful to you, but we will follow up. I think there's a few other things that could be helpful for that challenge. I'll see what we can provide internally. So I will get back to you. I would encourage you to register for the challenge, the Creative Copper Recovery. So that's probably where we will send that information out to for that group. Cool. Well, look,
can I say something before? Of course. Maybe the information that we're sharing today might look very not specific, right? This is the way we can do it in this way. But if you have something that you believe that can help us with these processes, of course, we have some admin work that we can put in place to share more in case we are interested in what you can say. Yeah.
Yeah, that's a great point, Claudia. I do think it's worth noting that, even for sharing some of those things for people involved in challenges, it is pretty quick for us to get NDAs in place. to share more information. So that tends to be the easiest part of the admin process for us to do. So we can certainly sort that out to get more information to people. So Amado asked when so the copper extraction challenge, we've actually kept open for, we haven't got an official closing date of that. We will be doing a first review of that in April, around mid-April. The reason for that is chalcopyrite leaching has been a challenge for the industry for many decades that's not solved. So we don't think we're going to get all the answers in a couple of months. And that we're going to learn as we go and keep these challenge open so that we can share how that thinking updates and for people to submit new ideas in an ongoing way. So it will be open for a while. Amazing. Okay, well, look, I know we still have a bit of time left, but I might have finished this up early if there's no more questions coming through. I'll hand back over to Jess to close out the session for us.
Yeah, look, I think that last point's a really important one, Holly. You know, very, very rarely do you see a silver bullet that solves a problem that's been around since the dawn of time. So we do believe that systemic change evolves over time, and lots of little pieces make up a grand gesture that can shift the system. So we look forward to iterating to create change with all of you. And I'm really grateful for everyone being here today. We'll be back next month, as always, talking about everything that we are most interested in, and we continue to have the door open for all the ideas that you think of that we certainly haven't thought to ask ourselves. We don't pretend to have all the answers, and we don't even pretend to have all the questions. So thank you for being with us today. Thank you again to Chris and Claudia and Holly for leading such a wonderful conversation. It's really important to be able to answer all those technical questions that you have, and the door is always open, right? So this is not the only time you can talk to us. Holly's made some commitments to follow up, and you can always reach out to us as well. Thanks again.